Dear students, under the lecture series on complex analysis, we are solving problems under differentiability. Now here we have problems which says that the given function is nowhere differentiable. In order to prove that a function is nowhere differentiable, it is enough if we show that the function fails to satisfy the CR equation. So if the CR equations are not satisfied, then immediately we can conclude that the given function is nowhere differentiable. Now here in the question, it is given that f of z is equal to real part of z. What is real part of z? We know that z is equal to x plus iy. And what is real part of z? It is equal to x. So now we shall prove that this function f is nowhere differentiable. So now in order to prove that the function is nowhere differentiable, it is just enough to prove that the CR equation is not satisfied. For that, first we shall write u and then we shall write v. Now if you see, we have only the real part. So there is no imaginary part and therefore v is 0. And what is ux? 1. What is uy? X will be treated as constant and so it becomes 0. Since v is 0, vx will be 0 and vy will also be 0. We know that the CR equations are ux should be equal to vy and uy should be equal to minus vx. We see that they are not equal because ux is 1 and vy is 0. So first condition is not satisfied. Second condition, uy is 0 and vx is 0. But though the second condition is satisfied, we see that the first condition is not satisfied. Even if one of the condition is not satisfied, then we say that the function has failed to satisfy the CR equation. And when it fails to satisfy the CR equation, we can conclude that the function is nowhere differentiable. Now here we have the second question. So f of z is equal to e power x cos y minus I sin y. We shall first separate the real and imaginary part. The real part u is equal to e power x cos y. And the imaginary part v is equal to minus e power x sin y. Now when you differentiate u with respect to x, so ux will be equal to e power x cos y. And what will be uy? E power x will come as it is. Differentiation of cos y is minus sin y. And here vx is equal to, differentiation of e power x is e power x only. So minus e power x sin y. And then vy is equal to minus e power x comes as it is. Differentiation of sin y is cos y. Now we know that the CR equations are ux should be equal to vy and uy should be equal to minus vx. Let us check it. Ux is e power x cos y and vy is minus e power x cos y. They both are not equal. Also, uy is minus e power x sin y, vx is also minus e power x sin y, which means uy is not equal to minus vx. So this is also not satisfied. Even if one of the condition is not satisfied, then we say that the function has failed to satisfy the CR equation and hence the given function is nowhere differentiable. Next we have one more problem under this topic. So from this we will separate u is equal to the real part 2x, v is equal to the imaginary part xy square. Next we shall find ux, differentiation of 2x is 2. And then what will be uy? It will be equal to 0. What about vx? Differentiation of x is 1, y square comes as it is. And then vy, x remains constant, differentiation of y square is 2y, so we get 2xy. We observe that. And what are the CR equations? Ux must be equal to vy and uy should be equal to minus vx. Let us check that. Ux is 2 over here, vy is 2xy. The first condition is not satisfied. Similarly, uy is 0 and vx is y square. This condition is also not satisfied. Even if one of the condition is not satisfied, the function has failed to satisfy the CR equations. Therefore, the function is said to be nowhere differentiable. So I hope you would have understood how to prove that a function is nowhere differentiable. It's very simple. We have to just prove that it does not satisfy the CR equation. Kindly follow the upcoming video lectures for more topics under these kinds of problem. Thank you.